Hello my scholars, you're welcome to my school YouTube channel. My name is Manuel and in today's video we'll be treating acid, bases and salt part 3. Please don't go anywhere, stick around and we'll be right back. You're welcome back to my school YouTube channel. Like I said earlier on, we'll be treating part 3 of acid, bases and salts. Now, let's begin. Bases. Already we have talked about what acids are. We have talked about the characteristics, the properties of acids. We have also looked at the chemical properties of acids. We have looked at the uses of acids, and now we are here with bases. What are bases? A base is any oxide or hydroxide that dissolves in water to yield hydroxide ion, that is OH minus, as the only negative ion. Remember, we defined acid and bases from the perspective of different scientists. We talked about Burstin, Lowry, we talked about Lewis, we talked about Arrhenius, okay? But among all of those definitions, we said that a base is any substance that dissolves in aqueous solution to produce hydroxyl ion as its only negative ion. If it were acid, substances that dissolve in aqueous solution to produce hydrogen ion as its only positive ion. So the other way we say that a base can also be defined as a substance which will neutralize an acid to yield a salt and water only. Of course, in the process we refer to as neutralization reaction. So whichever definition you give for bases, this will serve. Bases are substances, or they are oxides or hydroxides that dissolve in water or in aqueous solution to yield hydroxide ion as the only negative ion. Or bases are substances that react with acid in neutralization reaction to produce salt and water only as their product. Let's move on to the next slide. Examples of common bases, as you can see, we have sodium oxide. That's why we said they are oxides of metals, or hydroxides of metals are usually bases. Okay, so we look at this. Sodium oxide is one of the common bases, examples of bases that we have. Sodium oxide, that is Na2O. Na2O, okay, and then we see in solubility it is actually soluble when you dissolve it in water or in aqueous solution. We have calcium oxide is another one. CaO is slightly soluble. Okay, this is a calcium salt. Calcium oxide is the oxide of calcium. It's when dissolved in water or in soluble solutions, they are slightly soluble compared to the sodium oxide. We have potassium oxide also, that is K2O. That is the formula for potassium oxide. It is soluble when dissolved in aqueous solution like water. We have sodium hydroxide. This is very also common. Sodium hydroxide, NaOH. It's soluble when dissolved. We have calcium hydroxide. We have CaOH2. Ca in brackets OH2, that is the formula for calcium hydroxide, and that is also slightly soluble in aqueous solution. That's why this is referred to as a weak base. Okay, when we look at the types of bases, whether strong or weak bases, just like we looked at it about strength of an acid, we also have strength of bases, strong acid and weak acids. We have strong bases and weak bases also. So some of them which are slightly soluble, okay, those are weak ones, and those ones that are completely soluble, that means they dissolve, they dissociate completely when dissolved in aqueous solutions, we refer to them as stronger. We have potassium hydroxide, that is KOH, that is also soluble completely, and then we have zinc hydroxide, ZnOH2, that is insoluble in aqueous solution. Let's move on to the next slide now. Now, the metallic oxides are formed when metals burn in air and they react with water to form their corresponding hydroxide. I will say that again. Metallic oxide, that means oxides of metals, are usually formed. How do we form them? When the metals burn in air. When we talk about air, we are talking about oxygen now, because oxygen supports burning. Okay, metals burn in air and they react with water to form their corresponding hydroxide. We have an example here. This is a metal. Of course, sodium is in group 1 of the periodic table, okay, and then it has 1 electron in the atom shell. So we say group 1 elements usually are referred to as alkali metals, okay. Sodium is an example of that. If sodium reacts with oxygen, okay, we have sodium oxide, that means Na2O is what is formed. This is an oxide of metal, okay, and then this oxide of metal will now further react with water. That's it here, Na2O will react with water to form sodium hydroxide, which is the hydroxide of this metal, sodium hydroxide. Of course, this is a base, okay, this is a base, sodium hydroxide. So how do we form that? The metal is burning in air first to form sodium oxide, then sodium oxide reacts with water to form sodium hydroxide. Let's move on to the next slide. We often see many people calling bases, calling alkali, say properties of acid, then we say properties of alkali. Some say properties of bases, okay. The two of them, one is used in place of the other, one is all encompassing while one is a sub under the other. There's a difference between bases and alkali, okay. Alkali is a base which is soluble in water. Alkali is a base which is soluble in water. So which means alkali is a type of base. Okay, so if alkali is a type of base, it means that all alkali are bases, okay, but all bases are not alkali. Does it make any sense to you? Alkali is a base, so that means alkali is a type of base, okay, that is soluble or that can dissolve in water. So all alkali are bases, but all bases are not alkali. The main difference is in their solubility. Alkalis are water soluble bases, while bases are a broader category of substances that neutralize acids and may or may not dissolve in water. So bases might not dissolve in water and they might dissolve in water, but all alkali are usually soluble in water. They are water soluble substances. So when you are using one for the other one, you must know what you are actually using it for, the reaction that they are undergoing. All bases will not dissolve in water. Some can dissolve, can be soluble in water, while some might not be soluble, all bases. But for alkali, all alkali are water soluble bases. They are type of bases that are soluble in water. Therefore, all alkalis are bases, but not all bases are alkali. Examples of alkali include, we have NaOH, that's sodium hydroxide, we have potassium hydroxide, calcium hydroxide, magnesium hydroxide, we have zinc hydroxide, and so on and so forth. Let's move on to the next slide. A strong base, difference between, we talked about classification of acids. We said acids could be classified in terms of their sources, in terms of their strength, okay, and then form of their dissociation. Okay, when we talk about strength now, bases can also be differentiated or can be categorized in form of their strength. So that's why we have the strong bases and then the weak bases. A strong base, just like the acid, a strong acid will ionize completely in aqueous solution to produce negatively charged hydroxide ion. Remember that strong acid will dissociate or will ionize completely when it is dissolved in water to form hydrogen ion, to dissociate completely hydrogen ion. But a strong base will ionize completely in aqueous solution to produce negatively charged hydroxide ion, that is OH minus, and the positively charged metallic ion. Examples of strong alkali are, we have NaOH, that's sodium hydroxide, caustic soda. We have potassium hydroxide, that is another strong alkali, example of strong alkali. Now we look at the weak bases now. Weak bases, conversely, are metallic oxides, okay, or hydroxides, which are incompletely ionized. In other words, they are partially ionized in aqueous solution to produce relatively few ions. So they don't dissociate completely when dissolved in water, they dissolve partially or they ionize partially. And when they ionize, when they dissolve, they produce hydroxide ion as well as a counterpart of their positively charged ion as well. Examples of weak bases are, we have calcium hydroxide, we have ammonium hydroxide, we have magnesium hydroxide, we have so many of them, okay. These actually are weak bases. When you look at the table we had in previous slides, we said that we showed that some of them are slightly soluble while some of them are soluble. Those that are soluble completely are strong bases, okay, while those are slightly soluble are what refers to as the weak bases. Let's move on to the next slide now. We want to look at the physical properties of whether we say alkali or bases, okay, since we said all alkali are bases, okay, but all bases are not alkali. So it could be physical properties of alkali or bases. The first one is, we said alkalis have bitter taste. Alkalis have bitter taste. Like we have, please don't go and take an inorganic base and then you want to taste it, okay? Yes, like I told us in the previous part of this topic, we said that when you want to taste, it's advisable to taste organic acids, that like we talk about the ones we have in unripened fruits, okay? Unripened fruits, you can have a sour taste. When you take unripened mango, unripened oranges, unripened, fruits like that, you feel the sour taste in your mouth when you take them. So alkali usually have bitter taste. The second one is they are soapy to touch. When you touch them, just like how slippery it is when you touch the soap, that is how you can identify alkali or bases also. When you touch them, you feel them, they feel like soap. Of course, let's wonder why we have caustic soda, which is an alkali, in the manufacturing or in the production of soap itself. So you can feel that touch. So that is actually what is responsible for the what? For the soapy touch, the slippery touch that we feel in soap, because we use caustic soda, or what we use, alkali are used. And because all alkali actually have soapy touch, they are soapy to touch, they have that slippery touch when you touch the soap. That's how you can identify an alkali. The third one is that they turn red litmus blue, or they turn litmus blue. When you say red or you say blue, if you dip a red litmus paper into an alkali, the color changes to blue. If you dip a blue into alkali, it remains blue. So which means that whichever litmus that is dipped into the solution that is alkali, you will have the color as blue. So when it turns red litmus paper blue, it's another characteristic of physical properties of alkali. And the fourth one is concentrated forms of the two caustic sodas or caustic alkalis, that is sodium hydroxide and potassium hydroxide, are very, 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 very corrosive, okay? Whether it is sodium hydroxide, which is caustic soda, or potassium hydroxide, they are very, very corrosive. Let's move on to the next slide now. Chemical properties of bases and alkali. We have not the physical ones now, we are talking about the chemical properties. Don't forget that in one of the video lessons we have had in chemistry, we talked about the difference between physical change or physical reactions and then chemical changes. Remember, you can visit our video lessons to try to remind ourselves again of the difference between physical changes and chemical changes, okay? Usually, when we talk about chemical properties, we have them when no new substance, we have the reaction where a new substance is formed, okay, and they are not easily reversible, okay? But physical changes usually will occur when this new substance, of course, you say there is no new substance that is formed and they are easily reversible. Of course, you talk about difference between melting ice, okay, can turn to liquid and liquid can turn back to melting. That's a physical change. But if you burn your firewood, you have it turning into ashes, into charcoal. You can't bring the ashes and the charcoal back to form that wood, okay? So that is a chemical reaction and so forth. So when we talk about chemical properties of bases, we are talking about chemical changes that occur when that particular substance undergo chemical reaction. The first one we are looking at is reaction with acids. We mentioned this as one of the characteristics properties or chemical properties of acids also. So whatever reaction the base has undergone, the acid can also bases can also undergo. The first one we say reaction with acids. Bases react with acids to form salt and water only in the reaction we call neutralization reaction. So when salt is formed and water is formed from reaction between acid and bases, we say we have neutralization reaction. So you see sodium, this is the ionic form of sodium, and then the ionic form of hydroxide, positive and negative. This is cation. We have the radical here, OH minus, reacting with HD. So if you dissociate this will also be H plus, and then this is C minus, okay? So definitely this sodium is stronger than this, okay? So sodium can come in and displace this hydrogen from here. When it displaces it, sodium stays this. You have sodium chloride to be formed, which is what we have here. Then this hydrogen that was displaced reacts with this OH here to form H2O, which is the water we have here. So that's what happens in the neutralization reaction. We can also have hydrogen ion, which is the H positive that we have here, from the acid neutralized by the hydroxide ion or hydroxyl ion from the base to form the water molecules that we have here. So that's the first chemical property of bases. They react with acid neutralization reaction to form salt and water. Let's move on to the next slide now. Bases react with ammonium salt to liberate ammonia gas. Bases react with ammonium salt to liberate ammonia gas. Just like we talk about a confirmatory test when we are trying to look at the reactions of acids. We said whenever acids, okay, react with carbonate salts, okay, carbon oxide or carbon dioxide, CO2 must be liberated. And when acids react with metals, we said hydrogen gas, which is H2, must be liberated. Please keep those ones and your fingertips, don't forget them. So the same thing, like manner, we have bases reacting with ammonium salt to liberate ammonia gas. So you have, this is your base here, calcium hydroxide here, CaOH2, reacting with ammonium chloride to form calcium chloride. Of course, the calcium comes in here to displace this ammonium salt, NH4+, and then calcium comes in here to form CaCl, which is what we have here, Cl2, okay, because the charge of calcium is actually, the valency is +2, while for chlorine is -1. So usually when compounds form, we say one of the ways apart from bonding is that what they exchange their valencies. So the 1 for this goes to calcium, the 2 of this comes to this. So S, we have CaCl2. So plus water is formed, and then we have ammonia gas that is formed. This is a test to show that bases can react with ammonium salts and then ammonia gas will be formed. Let's move on to the next slide now. Uses of alkali. Of course, they find applications in the laboratories, they find application in industries, they find application in many companies or factories where production are taking place. We see, for example, they are used in the manufacture of soap, okay, glass, we have paper, and then we have some of them, some alkalis are used also in the softening of hard water. So these are just few of the examples or uses of alkali. We have come to the end of the preview of this lesson. If you want to have access to the full video, please click on the link in the description below that takes you to my school website. There, you'll be able to have full access to the video. And in the full video, we'll be looking at acidity, we'll be looking at alkalinity, we'll be looking at pH scale, we'll be looking at indicators, and so on and so forth. I believe you enjoyed this content. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video.